Hello engineers, welcome to the new video of the course, and in this particular video we are going to see that how exactly we are going to find out the value or the magnitude of any resistor. So first of all, let me show you the resistor. So this is how a resistor looks like. Okay, so as you can see over here, this is how a resistor looks like. Okay, the most important thing that you should notice over here is this. Okay, you see these are 4 lines. Okay, 1, 2, 3 and 4 lines. Okay, so what are those 4 lines and what are they trying to indicate? So this is what we need to find out. So let me just tell you that these 4 lines are nothing but these 4 bands. Okay, so we call it as bands, not lines. So these 4 lines are nothing but these are the bands, and not necessary that there will be 4. Some resistor might have 5 bands. Okay, some might have 6 bands as well. Okay, it totally depends upon the magnitude of the resistor. Okay, as of now I'm just showing you the example of 4 bands. So these are the 4 bands or 4 banded resistor. So 4 bands, what are these 4 bands? So these 4 bands, they combinedly decide the value of the resistor, decides value of a resistor okay, and here there is this particular table which you can see. Okay, so band 1 and these are the certain colors, band 2, and we need to refer that particular respective color to get the exact value. Okay, I hope this particular part is crystal clear. So now let's first see how exactly we proceed further when we want to find the value or magnitude of any resistor. Okay, so this is a resistor. Okay, great. Now this is brown color. Let me just give the names for the respective colors. So this is the brown color. Let me just show it with this particular color. Yeah, so this is the brown color. Okay, this is the black color. Okay, this is the black color. This is kind of orange color, and I don't have orange, so I'll just show it with this one. This is an orange color, and then this is gold. Okay, so this is the golden color. Okay, gold color. So we have identified these 4 colors, right? Now we need to put the values for that respective color. Okay, so now let's say if I take brown over here. Okay, so for brown we have 1, okay, 1, 10 and plus or minus of 1%. We have these 4 values. Okay, so we need to identify where that brown color is present, whether it is band 1, band 2, band 3 or band 4. Okay, so as I clearly mentioned, there are 4 band. I mean, this is a 4 band resistor, right? So brown color, is this my band 1, band 2, band 3, band or band 4, right? We really don't know. If let's say if I am starting from this particular position. Okay, let's say if I'm starting from this particular position. Okay, so this will be my band 1. Okay, but let's say if I'm starting from this particular position. Okay, so this becomes my band 4. Okay, and this will be my band 1 for sure, the gold one. Okay, but if I start from here, if I start counting from here, if I start giving the values for the respective band, so then this gold will become band 4 for me. I hope you are able to understand this. Okay, if I start to give the respective numbers for this particular band, okay, and if I'm starting from this particular position, so this brown will be band 1. Okay, this brown color will be band 1. Okay, on contrary, if I start giving the values for that respective band, so the gold will be band 1 from if I start from this particular position. So that's a kind of contradictory, right? So how to identify that whether gold is band 1 or it is band 4? Okay, or else vice versa. Let me erase this everything. Okay, so how to identify whether this particular gold, it is band 4 or it is band 1, or rather this brown color band, it is band 1 or band 4. Okay, so it's quite simple. We just need to see the gaps between the bands. So you see the gap, let's say this particular gap, let me change the color so that everything will be visible to you all guys. I hope this color is visible. Yeah, so let's say if this particular gap is G1. Okay, you see this particular gap, it is almost equivalent to G1. Okay, so my G1 is almost equivalent to G2. Okay, the gaps between these two bands and these two bands, they are quite similar. But now if you see this particular gap, let's say if it is G3, right? So G3, the gap 3, okay, the gap between these two bands, that is orange color band and the gold color band, okay, the gap between these two band, that is G3, it is greater than this band, that is G1, which is almost equivalent to G2, right? So that means what? That means this will be my fourth band. Okay, the moment you see a good enough gap between two bands, so that becomes my last band. If it is 5 band resistor, and if you see a good gap or a huge gap between two consecutive bands as compared to the previous bands, so you see over here the previous bands are brown, black and orange, so the gap between all of them is almost negligible, or it is very less. On contrary, the gap between the last and the second last band, that is orange and gold, it is quite maximum, right? Okay, so that means what? That means the last band where the gap is quite high, so that will be my last band. Okay, in this case, since we are dealing with 4 band resistor, so this becomes my fourth band. Okay, this becomes my fourth band, so gold color becomes my fourth band. I hope this particular part is crystal clear. So what I'll do, I'll keep it as it is. Okay, and we'll see how to proceed further. So you see first band is brown band. Okay, so you see band 1, hope this particular color is visible. Okay, so you see this is band 1 and we have brown over here, so the value over here is 1. Okay, we just need to see this particular part. Okay, so the value for this particular table is 1. We have brown band. Okay, and it is the first band as clearly mentioned, so this is first band. Black one is the second, right? Black one is the second band, orange one is the third band, and gold is the fourth band. Okay, great. So first band is brown, so you see for band 1 we have 1. Great, so we just need to write 1 over here, 1. Okay, then we have black. Okay, so black is present over here. You see black is present over here, and black is present at band 2. So we have value as 0 over here, so 0. Then we have orange. Okay, we have orange. Okay, so where is orange? So yeah, over here there is this orange. Okay, and orange is present at band 3. So this is my band 3, and this will be my band 4. Just write over here. Yeah, so at third band we have this particular value, it is 1000. Okay, 1000 is also referred as 10 raised to 3. So I'll write it as 10 raised to 3. I'll come to this particular point, don't worry why I wrote multiplication sign, you don't worry about that. Okay, because you see over here it is multiplication sign, and to the right side we have 1 and 3 zeros, so that means 1000, right? So that's why I wrote over here as this, that is multiplication sign, and if you want you can show it in this way only if you want. Okay, if you are not comfortable right now, so you can actually show it in this way. So multiplication sign, you see orange color multiplication sign over here at band number 3. So multiplication sign and then 1 and then 3 zeros. Okay, so what does that means? That means this is 1000. So I can represent 1000 as 10 raised to 3, right? So I can represent this entire thing as 10 raised to 3. So this is what I did earlier. Okay, I hope this particular part is crystal clear. Then for band 4 we have gold color. So at band 4 we have gold, and you just have a look over here. This is the gold, and here is the value, that is plus or minus of 5%. Okay, so we just need to write over here as plus or minus of 5%. Okay, so I'll just shift this entire thing over here. 1 sec. Okay, so what exactly is the value of the resistor? So the value of the resistor is 10 into 10 raised to 3 plus or minus of 5%, plus or minus of 5%. So what does that mean? That means the value of the resistor is 10 kilo ohm. Okay, and obviously there is always a scope of error, so plus or minus of 5%, so that becomes my tolerance. So this is the tolerance. I'll explain you this part as well, don't worry, just have some patience. So the value of this particular resistor is 10 kilo ohm. I hope this particular part is crystal clear. Okay, now let's proceed further and let's try to see this particular part. Okay, the part that we saw now with the help of this particular basic example. Okay, so just remember, whenever you see any sort of resistor, obviously they have not shown the enough amount of gap to identify which is the fourth band and the first band, but if you see, they have clearly mentioned this particular point. So the first two bands, if you are dealing with four band resistor, just remember this particular point. For 4 band resistor, the first two bands are reserved for digits, to write certain digits. Okay, then the third band is my multiplier. Okay, and the fourth one is the tolerance. Okay, so you just have a look over here. So these two bands, okay, so this one, so this acts as the digits. Okay, this one, this third band, it is my multiplier. So this is my multiplier. I'm just writing it in short form. So this is my multiplier, and the last one, that is percentage one, that is my tolerance. Okay, so in earlier case, if you see, we had what? We had brown. Let me just write over here. We had brown, right? I hope you remember that, brown. We had black as the second band, black. Then I had this as, if I'm not mistaken, that was, yeah, orange. Over here we had orange. 1 sec, let me just select some random color. So this was my orange. Okay, and the last one was gold, right? So this first two bands, they tell us the digits, right? Brown and black. So we just need to write those particular values. So brown, if you see, brown was present at band number 1, so the value over here is 1. Okay, so you don't worry that how exactly these values came. This is not the point of our interest. Okay, you just Google the color code of resistor, you will get this particular table. Okay, you don't need to just focus on that how exactly we got this particular values, what is all of these things and all. Don't worry about that. Treat it as the given information, and based on this particular given information, we are going to find out the value for the resistor. Okay, I hope this particular part is clear to you all, guys. So yeah, first is brown, so I'll just write over here as 1. Then next is black, so I'm going to write it as 0, right? 0. Okay, and then you clearly see, then we need to write into and 10 raised to whatever that value is. So the next color was orange. So if you want, you can just refer this particular table as well, that is multiplication sign and then 10 raised to 3, which I explained over here, right? So you can write this particular thing as well, right? I know I'm taking a lot of time, I'm again explaining the same thing, but believe me, this will help you to understand it in detail way. And then we have tolerance plus or minus of percent, and that is 5% for gold, right? Plus or minus of 5% of gold. Okay, sorry, plus or minus 5%. So this is how we actually find the magnitude of any resistor. So that is 10 kilo ohm plus or minus of 5%. So don't worry, I'll explain you this one as well, what exactly the tolerance is. Okay, but I hope that you understood the significance of each and every band that is been shown over here. Okay, now let's proceed further. Alright, so as you can see over here, there are two resistors and we need to find out the value for these two resistors. Okay, so the moment you see any sort of resistor, the first thing that you should focus is the number of bands that are present. So you see, for this particular resistor we have 1, 2, 3 and 4 bands. So this is a 4 band resistor, and in fact it is mentioned over here. Okay, similarly you come over here, so this is band 1, this is band 2, this is band 3, this is 4, and this is the fifth band. So it is a 5 band resistor, right? It is clearly mentioned over here, right? Okay, the moment we understand the number of bands, like how many number of bands are present, we can easily extract the other information based on that particular resistor as well. Okay, so what I'll do is that I'll just find out the value for this particular resistor. Okay, this one, and you need to find out the value for this particular resistor. Okay, treat this as your assignment or as your homework. Okay, so let's focus over here and let's first figure out the colors that are present. If I hope that this is visible. If it is not visible, don't worry, I'll just explain you the or I'll just tell you the colors that are present over here. So this is the red color, this is the red color, okay, and this is band 1. I'll write it as B1. Okay, and the second color is kind of purple or kind of violet, right? Since there isn't any purple color, so the closest color is this, that is violet color. So this is the band 2 is the violet color. So this is the band 2. Okay, so this is violet. I'll write it in short form, and this is my band 2. Okay, the third one is brown. Again, I'll just write it in short form. This is the band 3. Okay, and it is brown color, brown. And the last one is gold. You see, this is how the gold looks like. Okay, the last one is the gold. This is my band 4, and this is the gold color. Okay, so I'll just write it in the next page. So we have color as red, violet, brown and gold. Okay, great. So let me just write over here: red, violet, brown, and last but not least is gold. Okay, so these are the colors that are visible. Okay, now we need to find out the value for that particular resistor. What we know is that since it is a 4 band resistor, right, 4 band resistor, so first two bands, they are reserved for digits. Okay, this one will be the multiplier, and the last one will be the tolerance, right? Why I'm writing again and again? So that you should be quite comfortable in understanding what exactly I'm doing over here. Generally, I had seen most of the guys they get confused at this particular point, right? They are unable to find out the values for the resistors. Okay, but since you're learning from me, so you should not get confused at any point. Okay, it should be pretty easier for you all guys to understand this particular concept. Okay, so first band is band 1, that is red one, right? So this is band 1. Okay, band 1. I'll just move it little down so that I will be able to show the band numbers as well. So this is band 1, this is band 2, this is band 3, and this is band 4. Great. Okay, and as I had clearly mentioned that there should be enough amount of gap. So you see between band 3 and band 4 there is a huge gap, whereas if you see the gaps between band 3 and band 2 and the gaps between band 1 and band 2, it is quite less, right? So by default this gold band, this becomes my last band. Okay, great. Now let's try to find out the value. So first color is red. So for red we have 2. So I'll just write over here as 2. Okay, then we have violet. For violet we have 7. Okay, value 7. If you want, you can refer this particular table as well. You see band 1 is 2. One sec. Band 1 is 2, band 2 is 7, right? Violet. So that doesn't make any sort of sense. You can go with any of them, right? So yeah, the next color is violet. So we have number as 7 for that, right? For violet, you see 7. Then we have next color as brown. So for brown we have, so it, since it is a third band, right? So you see for third band, if you want you can refer this. For third band, if you refer brown, you will get this into 10, right? Or over here it is 10 raised to 1. Okay, 10 raised to 1. So multiply by 10 raised to 1, 10 raised to 1, or you can write 10. That doesn't make any sort of sense. And then we have plus or minus of the tolerance. For gold it is, you see, 5%, right? Plus or minus of 5%. So the value of this particular resistor is 270 ohms. Okay, so the value is 270 ohms, or if you want to be more precise, so that becomes 270 plus or minus of 5% ohms. Okay, something like this. Okay, now we are going to understand that what exactly is this 5%. We are going to understand this. So let me just write over here 270 plus or minus of 5%. What exactly is this? So this means, you see over here, 270 minus of 5% of 270. That means 5 by 100 times of 270, right? That is 5 by 100 times of 270. This is my 270, right? So 0 0 gets cancelled. That is 3 5s are 15. So roughly that becomes around, let me just calculate it. So that becomes around 13.5. So minus of 13.5, 270 minus of 13.5, so that becomes 256.5. okay, and if I take this particular value, that is let's say 270 plus of 5% of 270, right? So this is 5 by 100 times of 270. This is 270 once again. So 270 plus of 13.5, right? 13.5. So that becomes 283, right? So 283. So what exactly are these two values? So basically, in reality, you won't get the exact 270 ohms. Rather, you will get a specific range, right? Okay. So treat that particular resistor as a kind of error, right? Obviously, you won't get the exact value, right? But you will get a kind of range. So basically, the value which you got for that particular resistor, that is 270 ohms, we won't get the exact value. So this is kind of exact value, but this value is in range. I mean, you will get the range of that particular value, that is 256.5 if I'm not mistaken, yeah, to 283.5. that means what? That particular resistor, that means this particular resistor can provide resistance from 256.5 to 283.5, in between this particular range. Surely it cannot provide less resistance than this, and surely it cannot provide more resistance than this. Okay, but its actual value is what? 270 ohms. Okay, so this is kind of error, kind of tolerance, right? We prefer to give. Okay, I hope you are able to understand this. I hope this particular part is crystal clear. So this is nothing but this is a range of that particular resistor. Range. That is what tolerance is all about. And I believe that you understood this particular concept. It's pretty simple, right? It's pretty simple, and I hope that you also are able to understand that how exactly we need to find out the values for that particular resistor. Okay, now treat this as your homework. This is the 5-band resistor. I'll just give you the color code over here. So the color code is, let me check that. Color code is, so this is brown, black, orange and brown. Brown, black, orange and brown. So this is the color code. And by the way, this is the 5-band resistor. There is one hint from me. Let me just make it little big. Yeah. So this is the 5-band resistor. This is the most important thing. Band 1, band 2, band 3, band 4, and this is band 5. This is band 5 resistor. 5-band resistor. So in 5-band resistor, the first 3 bands, they are reserved for digits. Okay, so these are reserved for digits, the first 3 bands. The 4th band, it is reserved for it is termed as multiplier. Okay, and the 5th one, obviously it is tolerance. So I have given you enough information. Now it's your turn to find the value for this particular resistor. So let me know the value. It's fine even if you give me the exact value. I don't need the tolerance. It's fine even if you give me the exact value. Okay. And yeah, if at all you are facing any difficulty to remember this particular table, so there is a kind of short hint from me. So this is like a short form. You see BBROY, right? These are the color, right? So you just need to remember it in this way. That is BB Roy, ROY Roy of Great Britain. So G means green, B means blue. Great Britain has very good wife. Okay, and what generally women wear or wives wear? They wear ornaments made up of gold and silver, wearing gold and silver. Right? It's pretty simple. BB Roy of Great Britain had very good wife, or had very great wife, whatever you want to term, wearing gold and silver. It's pretty simple. I'll just write over here. So BB Roy of Great Britain had, this is of no use and also this is of no use, right? Very great or good wife. And what generally wives wear? They wear gold and silver, right? Gold, wearing gold and silver. Okay, and with this you can actually remember these terms. So B means black, right? So BB, black, brown, red, orange, yellow. G means green, right? B means blue once again, right? V means violet. G means gray, right? W means white, G means gold, and S means silver. So if at all you want to remember this particular table, you can actually remember it in this way. Okay, and you will get the tolerance and multiplier. You can remember as you try to solve lots of circuit, as you design a lot of circuits, so you will eventually remember this particular table. That's fine. Okay, that's fine even if you don't know, or even if you don't want to remember, that is also fine. Okay, but this is just a kind of short information in case if you want to remember this particular table, right? So with this we have completed each and everything about the concept of resistor. I believe that now you are in this stage to understand that what exactly a resistor is, right? What happens if I increase or decrease the overall length or the area of that particular material, and how exactly that particular conducting material gets affected when I change those two parameters, right? I mean the overall resistance of that particular material gets affected when I change the overall structure as in area and length of that particular material. Okay, so with this I'll end this session. I really hope that you enjoyed and you understood each and everything that we discussed till now. But still, if you have any doubts, if you're facing any difficulties anywhere, it's my request to you all guys that you please ask those particular doubts in the communication section, and I'll be happy to help you out there. So thank you for listening me patiently. I'm ending this video over here. Thank you.